All right, let's talk about something we've all experienced, but maybe never really thought about. Amazon's recommendation engine. It feels a little bit like magic, right? How on earth does it know what you're gonna want to buy next? Well, we take it for granted now, but the real story behind it, it's way, way smarter than you might think.
I mean, you know the drill. You toss something in your cart, and boom, right there it is. Customers who bought this also bought. We barely even register it anymore. It's so normal. But you gotta remember, back in the early 2000s, this was brand new. It was a revolutionary idea and a seriously difficult problem to crack.
So, yeah, how do they really know? How does a piece of software look at your cart and basically read your mind? The answer, as we're about to see, wasn't just about selling a few more things. Nope. It literally changed the internet as we know it.
Okay, so before we get to the brilliant solution, we really need to wrap our heads around the problem Amazon was facing. We're talking about a challenge of just staggering proportions. This wasn't about suggesting a couple of bestsellers. This was a data problem on a scale that was almost unimaginable at the time.
So first off, let's just think about the number of customers. By 2003, when the team behind this published their big paper, Amazon had, get this, 29 million customers. Just pause and think about that for a second. That's 29 million different people, with their own weird tastes, their own purchase histories, all of that data to sort through.
And then, on top of that, you have the catalog. We're not talking about a little boutique shop here. We're talking millions of different items. So now you have to try and connect every single one of those 29 million people to every single relevant item out of millions of products. It was, to put it mildly, a computational nightmare.
And here's the real kicker, the thing that makes this problem just insane. All of that number crunching, it had to happen in less than half a second, right there in real time on your screen. Any slower and you just click away. The pressure was immense.
So you get the picture, right? It was this impossible triangle. Massive scale, lightning-fast speed, and high quality. They had to give good, relevant recommendations to millions of people across millions of items and do it basically instantly. And the technology they had back then, it couldn't keep.
So what was the old way of doing things? I mean, before Amazon cracked the code, how did people even try to tackle this? Well, the most obvious approach, the one that makes the most sense on the surface, was to try and find your digital twin.
This idea is at the heart of something called collaborative filtering. Basically, the thinking was, let's get recommendations from people like you. The algorithm would sift through everybody, all the users, find the ones who bought and liked the same stuff you did, and then say, hey, here's some stuff they bought that you haven't seen yet. Sounds pretty smart, right?
So this led to a couple of different ways to do it. On one side, you had this super precise filtering. The recommendations were good, but it was just painfully slow because it had to compare you to literally everyone else. Then, on the other side, you had these cluster models. They were way faster, sure, but they worked by just throwing people into big buckets, like people who like sci-fi books. The recommendations ended up being pretty generic. But notice the pattern? Both methods were trying to answer the exact same question. Who out there is just like you?
And that right there, that was the fatal flaw. The whole approach was doomed from the start, at Amazon's scale. I mean, imagine trying to find your 5 best friends. But to do it, you have to personally interview every single person in a city of 29 million. It's impossible, especially when you've only got half a second to do it. These older methods they buckled. They completely broke under the weight of all that data.
And this is the moment where everything changes. The engineers at Amazon had this realization. They weren't just failing to solve the problem. They were asking the completely wrong question. And their new idea, oh, it was so simple, it was brilliant.
Okay, here it is, the big idea, and I'm quoting directly from their paper here. Rather than matching the user to similar customers, item-to-item collaborative filtering matches each of the user's purchased and rated items to similar items. Did you catch that? That's it. That's the whole game. They stopped looking for similar people and started looking for similar items. This was the aha moment, the breakthrough.
Think about how much that flips the entire problem on its head. The question went from, who are you, to what is this thing like? Instead of trying to find your digital twin, the system was now asking, okay, people who bought this Harry Potter book, what else do they typically buy? It might sound like a small change, but it's a massive shift in perspective. The algorithm wasn't really analyzing you anymore. It was analyzing the relationships between items.
Okay, so that's a brilliant idea, but how do you actually make it work? How do you build a machine that can do this at Amazon's insane scale? Well, the genius wasn't just in the idea, but in how they put it into practice.
It really boiled down to 3 clever steps. Okay, step 1, the algorithm chews through all the purchase data and builds this giant similar items table. Think of it like a massive map that shows which items are frequently bought together. Now, step 2, this is the secret sauce. This is the really clever bit. That huge, expensive calculation, they do it all offline, before you even open your browser. It could take hours. Who cares? It doesn't matter to you. Because then, step 3, when you actually visit the site, the system just has to do a super quick, simple lookup on that table it already built. It's just brilliant.
And the payoff was just huge. Suddenly, the system could scale like crazy because the part that happened in real time was super simple, it was incredibly fast, the recommendations were amazing because they were based on what people actually do, not some weird demographic bucket. And get this, it even worked for brand new users who hadn't bought much. It ticked every single box. It solved the whole billion-item problem.
And here's the thing, this wasn't just a big deal for Amazon. This breakthrough really laid the foundation for the entire personalized internet that you and I use every single day.
You know, this little feature, your recommendations, it became the new standard. The thing that started as a clever way to sell more books ended up becoming something we all just expect. From the shows Netflix suggests to the music Spotify queues up for you, it all comes from this same core idea.
And that's really the lasting legacy, isn't it? This item-to-item approach wasn't just a nifty feature, it became a foundational technique, a core building block for the modern web. It taught an entire industry how to take mountains of data and use it to create a unique, personalized experience for every single person.
So this idea, now over 20 years old, was one of the first giant leaps in teaching machines to actually understand something as fuzzy as human taste. And as these systems get smarter and smarter, you really have to wonder, what comes next? Where does this all go from here?